We orbit around the black hole at the center of the Milky Way galaxy. That's why we're here today to talk about this on the internet. We're not swallowed up by a black hole because we orbit around them. However, are there wandering black holes? And the answer is yes. In fact, we've been able to track wandering black holes as they wander through the galaxy. One day, one of them may catch up with us and eat us for breakfast, and it wouldn't even burp in the process.
If there's one thing that is both true and astonishing, it's the black holes. These mysterious phenomena in the universe have always puzzled us. If you want to spot a black hole tonight, just look in the direction of Sagittarius. There, at the center of our galaxy, lies a black hole weighing millions of times the mass of the Sun. Black holes are among the most powerful entities in the universe. They're like a mix of space-time and matter, all packed into one point, capable of swallowing anything they encounter. We've known they're powerful, but many details remained unknown until now. This image is the key. The dark circle in the center is the event horizon, the point of no return. Once you cross it, you're gone forever. Scientists have been studying black holes for decades, and they've finally uncovered their inner workings. Join us as we delve into what it's truly like inside a black hole, and how this discovery might change everything. Before we get to the recent discovery, a bit of history is necessary. Back when we were kids, black holes were just a theory. It wasn't until the late 1960s that we found the first black hole, known as Cygnus X1. This discovery gave us insights into how black holes function. We learned that black holes are incredibly dense regions of space-time with gravity so intense that nothing, not even light, can escape. They come in various sizes, with the largest being around 200 kilometers across, and the smallest no bigger than an atom. Cygnus X1 is a stellar mass black hole, only 6 times larger than our Sun, but with the same mass. It also showed that black holes have strong magnetic fields and immense gravitational pull, making them potentially destructive in the universe. This discovery paved the way for understanding these enigmatic phenomena. We also discovered how rare black holes are. There might be over 1 million in the Milky Way alone, but they're incredibly hard to detect. Some believe there could be even more. With so many in our galaxy, we needed to learn more about them, leading us to unravel the secrets of what's inside a black hole. When something enters a black hole, it gets trapped and compressed until it reaches a singularity, the central point where all matter is crushed into one particle. But before reaching this point, there are 2 layers to pass through. The first is the outer event horizon, a boundary where anything entering can't escape due to the strong gravity. This layer slows down and traps anything that falls into it, and escaping would require moving faster than light, which is currently impossible in our understanding of physics. This is also where our known physics gives way to a new set of laws that govern what happens inside. The second layer is the inner event horizon, a passage leading to the singularity. Here lies the true danger once a particle enters this layer. Survival or escape becomes nearly impossible, and it's destined to be compressed into a single point of matter. Gravity here is incredibly strong, bending even light, slowing down time, and creating unimaginably high temperatures. Matter not only gets crushed, but is also subjected to extreme heat. The challenge with black holes lies in their varying gravitational forces, making them hard to study and predict due to their unpredictable nature. What complicates matters further is that, due to their intense gravity, it's impossible to observe black holes directly. Scientists rely on observations of nearby stars orbiting these entities to gather meaningful information about their interiors. Imagine trying to understand this immensely powerful thing in space, existing in 3D, while we can only study it through telescopes and 2D images, never going inside because there's no return once you enter. But the problem goes beyond this. The fundamental issue is that we can't escape a black hole's gravitational pull with current technology, limiting us to distant observation. To study them, scientists must analyze the radiation they emit and the surrounding dust and gas. This makes it extremely challenging to create a detailed image of their interiors, because any probes or cameras sent into space would be crushed by the event horizon upon reaching it. Additionally, each black hole is unique, lacking a standardized model for formation and behavior. Physicists struggle to understand the singularity at the core of black holes, as we lack the capability to reach it due to speed limitations. As a result, all we can do is theorize about what lies within, and we won't truly know until we can surpass the boundaries of space-time and achieve faster-than-light travel. Complicating matters further, black holes constantly change and evolve as they consume matter, energy, and radiation from the universe. This means that any data gathered from observing a black hole at a certain point in time can quickly become outdated as the black hole transforms over time. Despite the danger and mystery surrounding these massive astronomical phenomena, they can still be partially studied and understood. By mapping stars near black hole event horizons, scientists can observe them from a distance and gain insight into their structure and behavior. This knowledge has allowed us to safely explore space and develop theories about what might lie beyond these mysterious entities' event horizons. Scientists have come up with intriguing theories as they've delved into these enigmatic entities. This theory about black holes suggests they might not be mere vast emptiness, but potential gateways to other galaxies and universes. The inspiration comes from the movie Interstellar, where characters venture through a black hole to find a new home for humanity. If this theory proves true, black holes could offer us a path to faster-than-light travel. This would mean navigating through them to reach distant galaxies and universes unrestricted by the usual limits of space and time. However, it's still highly theoretical because it hinges on developing technology that can surpass the speed of light. Furthermore, there are obstacles to overcome. The immense gravitational pull of a black hole could trap any spacecraft entering it, and the intense radiation around black holes poses potential dangers to spacecraft. What lies beyond the singularity of a black hole remains a mystery. Nevertheless, scientists are already working on spacecraft capable of faster-than-light travel. If successful, black holes might be among the first subjects for exploration. There's evidence that holograms are indeed real, as we've discussed earlier. However, studying these enigmatic sources of energy is challenging. Enrico Rinaldi took a different approach by combining two common theories about black holes, particles, and gravity, known as quantum matrix models. Rinaldi introduced a new theoretical concept called holographic duality. This theory proposes that when we observe a black hole, we should see it as a hologram. It suggests that the surrounding space plays a significant role in a black hole's operation. Rather than being a single point where all matter condenses, it's part of a continuous energy cycle. According to Rinaldi, the particles and gases in outer space provide the energy that fuels a black hole. In this holographic view, we can witness how these elements interact and combine to create something new. This differs from the traditional understanding of black hole behavior. Instead of a static point where matter is compressed, we should consider the possibility of a mobile black hole. It continuously consumes particles and gases from its surroundings, perpetually growing. This implies that even if a black hole moved near a planet, it could still consume matter and increase in size. The implications of this theory are exciting, potentially leading to a better understanding of black holes and their behavior. If we can unlock their mysteries, we might harness their energy for practical purposes. While it's uncertain if this theory is correct, it offers a captivating perspective on these powerful objects. As technology advances and our knowledge of black holes expands, the potential for new discoveries remains open. Time will reveal what secrets await. In the realm of black holes, things are bound to become increasingly fascinating, and we'll be here to share it with you. That's enough for today's video. Do you have your own theories about black holes? Share them in the comments below. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more content like this. We look forward to seeing you in the next one.
Yeah.